measurement DI. It's one of the sort of gateway points to make sure that you can do a maths assignment for year 11 at least, if you keep doing maths in year 11 and definitely going into year 12. Okay, so today's lesson, the first thing I need you to do is to go on to DayMap, today's lesson note. Can you please download 2025 Summative 10 Ignite Measurement DI PDF? That is the task sheet. And can you also download Exemplar Measurement DI Upload.pdf? Can you download those two things? It might be useful for you to put them into a folder, maybe on your desktop or in your 10 Maths Ignite folder. Once you've downloaded those two things, can you please open the task sheet? We will read through them. This is what the task sheet looks like. So part of this video is demonstrating how I'd like you to expect how an assignment should be introduced. Step 1, I'm present, so I can explain to you the instructions. If you have any questions about the task sheet, I'm here for you. Number 2, this will be recorded. So if I'm away, you'll be able to refer back to it, okay? Can you have a look at the task sheet, please? So can we keep in mind you have a maximum of 8 pages. Size 10 font is the smallest you're allowed to go. Those expectations are SACE Stage 1 expectations. So SACE doesn't care what your margins are, as long as it would print. So margins, what am I talking about margins-wise? It's these spaces on the left and right, and the top and the bottom. You can make them, if you're struggling to fit in the words, you can make them as small as you like, as long as they would print. Okay, they don't care about the margins. In SACE, all they care about is the 8 pages for the main body of the assignment, not including references and appendices, which we'll talk about after, and they care about the size 10 font. We cool with that? Let's move on. So what are you going to be doing? You'll be using mensuration, not menstruation, that's a biological thing. Mensuration is measurement maths. And what you're doing is investigating the relationship between the surface area to volume ratio as the size of objects increase. These objects are going to be used to model the shape of a baby, and analyzing the results are going to allow you to explain why mathematically babies are more vulnerable to hypothermia and dehydration. So you are doing measurement maths, and the context is that you're trying to explain mathematically why do babies suffer from heat death in cars compared to adults. It's got to do with the amount of surface area or skin they have for the volume of their body. Okay? And you'll find that out as you do this assignment. So your report, I need an intro. Don't worry about the writing part of it until you've done all the maths. So leave the intro for now. Focus on this. You'll have the rest of this week to do maths calculations. You'll do week 10 unless you're on snow trip. And then you'll have week 1 of term 3 to do it. I really don't want you to do it for homework over the holidays. Have your holiday, okay? And then the rest of the write-up you can do after. What I want to do today is to assist you with starting part 1 so you can hammer out a bunch of maths. So let me go over some of the context. If you guys watch the news, you would realize that pretty much every summer another child dies in Australia from heat death because they're left for like 10 minutes. Why does that occur? It's all to do with the surface area to volume ratio, which is comparing an object's exposure to the environment and the context of that object. In living things, the surface area to volume ratio is governed by many things like size and shape that determine their survival in different environments. Heck, I referenced that. Actually, mathematically, the surface area to volume ratio is a key reason why children in a locked car die faster than adults do. So your context of doing all this measurement stuff is to explain why that happens, okay? So part 1. This is what I think you should start off with right from the start of this double. I can check your maths instantly. I've got spreadsheets for that. So number 1, part 1, step A, choose a simple solid with your own dimensions and find its surface area and volume. Am I giving you a choice there? Choose. What are the 3D shapes that I've shown you how to find the surface area and volume recently? Could you do a cube? Could you do a sphere? Could you do a cylinder? Could you do a pyramid? Just choose something and decide how tall, wide it is, how deep it is. find its surface area and volume. That is step 1. Okay? Step 2, find the surface area and volume of that same solid, but you double the dimensions. So it's twice as large. The scale factor is 2. So you do the same maths again, but it's double the size. Any questions about that? That's steps 1 and step 2. Step 3, make a prediction about how the surface area to volume ratio might change as the dimensions of the solid get bigger and bigger. You do not need to be right. You're Ignites, and every year people are like, what if my prediction is wrong? That's the point of a prediction. You're proving whether you're right or wrong. It's like a hypothesis in science. You don't need to be right. Just say what you think is going to happen. After that, step D, apply the next 6 whole scale number factors, so you're going from 1 to 8. So it's kind of repetitive, but on Monday, did I give you a shortcut to find the surface area and volume of things as they get bigger? So it shouldn't take that long, okay? You'll fill in the table with that information. You're going to do a little graph showing how the surface area to volume ratio changes as things get bigger, and then you're going to analyze those results according to these dot points here. That's part 1 of the assignment done. That's the first half. I think a lot of you will be able to get to, before you go on holidays, where you design something that vaguely looks like a human baby. That's where you're going to do your sketchy Google searches and go, how wide is a baby's neck? What is the diameter of its head? Okay? Those are going to be on your searches because I want you to make a little 3D, little cute baby. Okay? It doesn't need to be scientifically or biologically accurate, but if you want it to have a little thing, then that's fine by me. I can't argue with you because if it's meant to be male, it's a male. Okay? But try to make it vaguely baby-like, because does that look like the proportions of a baby? Babies tend to have a large head, a squat body, really thick thighs. They be packing in those cake, okay? All right? But that would be after. And basically, once you've found your baby shape, you're going to do part 1 again, but on the whole baby shape. All right? Any questions about that? Guys on the back desk, any questions about those first steps? I think a lot of you could finish part 1 today, and I'll check your maths. The other thing I wanted to show you, so we've read through the task sheet together. After I've stopped talking, recording the video, I'm going to give you time to actually work on it. What are the other things on DayMap? On DayMap, there's going to be a materials package that goes all the way until it's due. You can see that this reminds you when the draft is due. I want the draft by midnight Friday of week 1, term 3. That weekend, I'm going to be busy giving you feedback, very detailed feedback. I'll show you. I can't show it on the video because if I open my emails, you're going to see a bunch of names. I'll show you what the feedback looks like after, okay? And then the final will be due a week after. Here are attachments that will help you. All the attachments you need are right there. There is an exemplar, DI upload. That is from the sister of one of our current students. It's one of the best ones that I've seen. But I haven't opened it fully. It's sort of covered and it's got comments to show you what the DI is about. Just don't plagiarize it, okay? And it's not AI generated. It's by a student, okay? And lastly, there is a measurement DI full guide. So the last thing I wanted to show you for this video here, I recorded a video. I ran this assignment with a mainstream class, and they were sort of just, they didn't really want to start on anything. They were sort of just mouth breathing, okay? So I did a video that took half an hour of me just doing part 1 completely, okay? If you need help just doing the assignment, just follow this, okay? The only thing with the video is I only do 5 scale factors. Their expectation was lower. You're meant to go from 1 to 8, okay? So don't follow the video for your expectations. It's 1 to 5 on the video. You're meant to do 1 to 8, okay? So hopefully that goes over the supporting materials. Any questions before I stop? Yes?
So what exactly are you grading this on?
Sorry?
What are you grading this on?
I'm grading you on what your final assignment looks like. So how could I open this without... Okay, I'll download this. Your assignment will look like this except for all the hidden parts. So I've shown you the gist of what this person's intro says. You can see references there, but that stuff that's been blanked is her enrichment of the context. She found more references there, and I've summarized what she did in hollow text there. So she wrote an intro. She introduced part 1. Can you see she calculated the first shape? What shape was it? Sphere. Then she found one that was double the size. Then she did all shapes up to size 8 and filled in the table. Then she drew a graph. This was the only thing I took marks off because those numbers should be on the lines, not in the middle. It's a pedantic thing, but I'm a pedantic person, okay? But what can you see about the surface area to volume ratio? When you're small in size, what is your surface area compared to your volume? Very high. As you get bigger, what happens to the amount of surface area on your body compared to the volume or size of your body? It gets lower really fast, lower again, and then the lowness, it sort of flattens out. So what is that saying? When you're a baby, you got a lot of skin for the amount of water in your body. When you're slightly bigger, still a lot of skin for the amount of water in your body. But as you're bigger and bigger, is it changing that much? Does that sort of explain why babies will suffer from hypothermia more? Where does heat come through? Your skin. If you've got a lot of skin for the amount of volume in your body, you're going to suffer more than someone who's larger in size. That's the general argument. You need to develop the evidence for that. Okay? So you could see there's her analysis. I've given in dot points what her analysis was. I don't want you to copy it. Okay? Maths calculations part 2. This is what her baby looked like. It's got feet and everything. Then she did the same calculations again. She filled in the table. Yeah, it was weird. Why did she do this graph correctly? See how the dots are on the lines versus before they were in the middle? So this one was right. The first one was just a bit weird. And then a little discussion. You guys were really good at the discussion of the projectile motions thing, so I'm not so worried about this. What is an assumption made? Does a baby T-pose while sitting in a car? Yes or no? Do they generally tend to sit? That's an assumption that's made in this assignment, for example. So that's basically what it looks like. Limitations, you've got some examples there. And then you can see she referenced a lot. You don't need that much. That's ridiculous. And then appendices. Have you heard of appendices before? Appendices is a section in the DI that's not worth any page limit, and it's where you put repeated maths. Is your maths going to be repetitive? You're going scale 1, scale 2, scale 3, scale 4. It's not valuable to show me that you can do that repeated maths over and over again in the main body. It's just going to take up space. So you chuck it in here. See how she's got scale factor 3 here, scale factor 4, scale factor 5. Why do you do that? It doesn't take up page space in your 8-page limit. Okay? That's all she did with the appendices. Yeah, but you've got that exemplar, so you can have a look. Any other questions? No? I'll stop there.